My name is Pragati Misra. In my last video, I have discussed about the topic reducible to exact differential equation, which was the eighth method to solve a differential equation. There are 5 methods to solve an unexact differential equation by reducing them. Okay, so I discussed about rule number 1 and rule number 2 in my previous video, so you can watch it there. And today is the time of discussing rule number 3. So what is rule number 3? If 1 upon n d by m upon d by y minus d by n upon d by x is a function of x alone, say fx, then integrating factor is equals to e raised to power fx dx. What does it mean? You can understand it. Since we have given m and n in the differential equation, so we will partially differentiate them with respect to y and with respect to x, and then we will put them to here. Okay, then we can find the value of this term, and if it is the function of x alone, then we can find the integrating factor as well, and then we will multiply this integrating factor to the differential equation. Then the differential equation got reduced into the exact form, and then we can easily find the solution by previous method. Similarly, we can understand the rule number 4 as well. It says that if 1 upon m d by n upon d by x minus d by m upon d by y is a function of y alone, you can see it is just reverse of this. And if it is a function of y alone, then we call this function as f of y, and in that case the integrating factor will be e raised to power f of phi of y dy. Okay, so in both methods are similar, but there is some distinction that you can understand easily. I will take examples for both the rules so you can understand it easily. Taking here, you can see this is m, this is n. If I calculate d by m upon d by y, then this gives me 4xy cube, and if we calculate d by n upon d by x, it gives us 0. So you can see both are not equal, so the given equation is not exact, and we will try to reduce them into the exact form. Okay, so here you can see this is not homogeneous form, and this cannot be solved by second rule as well, because here not y is common and here not x is common, so we cannot apply the above 2 rules. Okay, so we will apply the rule number 3rd, and what it says, we will check that what is the value of 1 upon n d by m upon d by y minus d by n upon d by x. If it is a function of x alone, then we can apply the rule number 3. So what is the value of n? You can see 1 upon 2y cube d by m upon d by y is equal to 4xy cube minus 0 is equal to 4xy cube upon 2y cube. Okay, 4 get cancelled by 2 and y cube get cancelled by y cube. So what I am getting here, 2x, which is the function of x alone because 2 is constant. So this is our fx. Now you can see that if we are finding this value, then it is the function of x alone. Then we can find the value of integrating factor. What is the formula of this? Integrating factor is equal to e raised to power fx dx. And our fx is 2x. So e raised to power integration of 2x dx. E raised to power, if I integrate it, we get 2x square by 2. So 2 get cancelled by 2. And so the integrating factor is e raised to power x square. So we got the value of integrating factor. So we will multiply them by the given differential equation with this integrating factor. So now we will multiply the given equation by the integrating factor e raised to power x square. And after multiplying, we get that x cube plus xy raised to power 4 e raised to power x square into dx plus 2y cube e raised to power x square into dy is equal to 0. So now you can see here we are getting a new m and a new n. So we will see that whether this equation got reduced into exact form or not. So we will check first. Okay, so I am going to check what is the value of d by m upon d by y. So you can see the value of this is 4x e raised to power x square y cube. And d by n by d by x is equal to 4x e raised to power x square y cube. So you can see both are same. So the condition of exactness is verified. That is d by m by d by y is equal to d by n upon d by x. So now I can apply the next method, that is the solution method. That is equation becomes exact. M dx taking y as constant plus integration n dy, and should be free from x. That is, we remove all those terms which contains x, and that is equal to integrating constant. Firstly, I want to show you the value of nu m that I calculated and the value of n that I put here. Okay, so we will see that the value of m is this and the value of n is this. Here you can see the n contains the terms of x. So n, we have to omit this. That is, the value of n nu n becomes 0 after putting it into the integration. So we put the value of m this, and the value of n should be 0 here, and that is equal to integrating constant. If we separate them together, if we separate them, then what we get? We multiply it by 1 by 2 and divide it by 2. If we multiply it by 2 and divide by 2 as well, then it can be solved by substitution method, and we are separating it. So I will put x square as t, and that gives me 2x dx is equal to dt, since you can see this form. Okay, so if we put this, then we get 1 by 2 t e raised to power t dt plus y raised to power 4 by 2 integration of e raised to power dt. Since we are putting at the place of x square as t, and 2x dx become dt, and that is equal to integrating constant c. So we will apply the Elet method to solve this integral. So if we apply this, that what is the method? That is, we will put the first function as it is, and then we take the integration of second function, and then we apply further method. You understand this because this is the 12th class concept, so I am not going to tell that. Okay, plus 5 power 4 by 2 e raised to power t, because the integration of e raised to power t is e raised to power t, is equal to integrating constant c. If I simplify this, because we have taken t as x square, so we have to put them at the last of the result. Okay, so x square minus 1 e raised to power x square plus 5 power 4 by 2 e raised to power x square. Here you can see 1 by 2 is common in both terms, so we can take it as an arbitrary constant. So I am going to take that as an arbitrary constant. So the term which is right side is x square minus 1 plus 5 raised to power 4 e raised to power x square, because e raised to power x square is common in both terms, and that is equal to integrating constant 2c. So this is the required solution. This is the required solution. So this is the required solution for this question. Now I am going to take one more example to show that how we can apply the rule number 4 to any question. So this is our next example. Now you can see the value of m is this and the value of n is this. So I am going to write the value of m, that is equal to 3x square y raised to power 4 plus 2xy, and n is equal to 2x cube y cube minus x square. If we differentiate it partially with respect to y, what we get? 12x square y cube plus 2x, and d by n by d by x is equal to 6x square y cube minus 2x. So you can see both are not equal, so the given equation is not exact. not exact. So we will try to make them exact. And what was the rule number 4? We will apply the rule 4 here. Okay. So what was that? 1 by m. Firstly, we will try to find the value of this. 1 by m debha n by debha x minus debha m by debha y. We will try to find out the value of this. If the value of this term is a function of y alone, then we can apply the rule number 4. So firstly, we have to check this. Okay. In all the cases, 1 by 3x square y raised to power 4 plus 2xy, and if we put the value of debha n by debha x, what is it? 6x square y cube minus 2x minus 12x square y cube minus 2x. This is the value. So if we solve it, what we get? Minus 6x square y cube minus 4x upon 3x square y power 4 plus 2xy. I can take 2 common here, minus 2. So what I get? 3x square y cube plus 2x. And here I can take y as common in the denominator. Then what I get? 3x square y cube plus 2x. Now you can see this term got cancelled by this term. Then what I get? Minus 2 by y. Here you can see this is the function of y alone. So I will take it as phi y. Now I can find the value of integrating factor by rule 4. What was the value of integrating factor? Integrating factor is equal to e raised to power integration of phi by dy. So I will put it here, e raised to power minus 2 by y dy. It gives me e raised to power minus 2 log y. And if I use the property of log, it becomes e raised to power log y raised to power minus 2, which gives us e raised to power log 1 by y square. Now you can see the value of this term is 1. So our integrating factor is simply 1 by y square. We got the value of integrating factor. Now it's time to multiply this integrating factor with the given differential equation to reduce the given differential equation into exact form. So here you can see the differential equation becomes of this form, and I have multiplied the integrating factor to the given differential equation. So the equation takes the form of this. Now is the time to multiply the integrating factor with each term. So what I get? 3x square y square plus 2x by y into dx plus 2x cube y minus x square by y square into dy is equal to 0. So we got the new m and new n. Now we will check that whether they are reduced into exact or not. So first we will check what is the value of debha m by debha y. You can check. I am not going to check that because the video is getting too long. Okay, debha n by debha x is equal to 6x square y minus 2x by y square. You can check it by yourself. Both of these values, that is debha m by debha y, debha n by debha x, both are equal to this term, and this represents that the equation becomes exact. So we can write the solution for this equation. Hence the solution is what is the formula of solution? M dx, where we take y as constant, plus n dy, where n should be free from x. That is equal to integrating constant c. So we will put the value of m and n here. I want to show you that we have to treat y as constant in this case, and we have to remove all those terms which contains y here. So you can see in n these terms also contains x and this term also contains x. So we get n as 0 in this integral. Okay, then I'm going to integrate it and putting the value of m and n. What will be that? You can see here 3x square y square plus 2x by y into dx, and this integral becomes 0 because the value of n is 0 here. Okay, since in n both terms contains x, you can understand. Okay, so I'm going to integrate it. What we get? 3x cube by 3 into y square plus 2x square by 2y is equal to c. So 2 get cancelled by 2, 3 get cancelled by 3, and our original solution is x cube y square plus x square by y is equal to c. So this is the solution for this equation. This is required solution. Okay, so this was the method to solve the given differential equation by rule number 3 and rule number 4. I discussed about the rule 3, rule 4, and take one example for rule 3 and rule 4 as well. In my next video, I will discuss about rule number 5. So please, if you are liking my content, please subscribe my channel. Thank you.